In this episode of What's What, we are going to talk about the flow of electricity. I will break down the properties of electric charges and electric currents, then highlight the difference between energy and power. I might show you how to interpret your electricity usage as well. After all, who does not want to cut costs on their electricity bill? I know I could use a circuit break. Get it? Anyone? My jokes never land. First and foremost, let's talk about electric charges. In an electromagnetic field, there are positive charges and negative charges. You may have noticed, positive charges attract negative charges, and negative charges attract positive charges. Oh, how opposites attract. But in science, like charges always repel from one another. Now, let's imagine this sequence within a given conductor, say, a copper wire. Here we have current intensity. Current intensity refers to the flow of electrons through a given conductor. The more electrons within that material, the higher the intensity. To make this process measurable, a unit was created. Anyone knows what that unit is called?
Is it the amp?
Well, it is. Bonjour, Vanessa. Do you know who the Ampere is named after?
The amp, short for Ampere, is named after André-Marie Ampere, the French physicist. He's like the king when it comes to modern electromagnetism. So, Frédéric, do you mind if I chime in?
Do I have a choice?
It would be rude to say no.
Take it away.
I know he appreciates me deep down. So, there are conductors, and electricity, it flows through these conductors. And an amp meter is usually placed in the circuit to measure the intensity of the electricity. So for all of you musicians out there, an amplifier is called an amplifier because it amplifies the intensity or the power of your musical instrument. So turn it up and keep playing. As long as your whole family isn't working from home, I guess. So what about voltage? How does that work? Voltage is what drives the electric current. It's the electromotive force that pushes free electrons from one atom to another. In a sense, it's kind of similar to how gravity dictates the flow of a river, or how the wind dictates the flow of the ocean. Voltage dictates the flow of electricity. Without voltage, electrons wouldn't move at all. And no movement means no friction. No friction means no electricity. No electricity means no energy. And no energy means no power. And what's the difference between power and energy? Well, power is the amount of energy that's used to operate a given device or utility. And this is measured in watts.
Hence the name of our channel, What's What?
Exactly. And energy, now that's measured in joules or kilowatts per hour. Mind-boggling, I know. Well, in regards to electricity, power and energy, they're often confused. So just remember, power measures the capacity of energy, where energy is measured by its rate of delivery. Your light bulb requires power to be operational, and that power is delivered by a constant flow of energy. In this case, energy equals the power that your light bulb needs multiplied by the duration that you're using it for. Honestly, those brain gifts never get old. But wait, Frédéric, I have one last question for you. How do I conserve energy to keep my electricity bills low?
Aha! Who needs answers now?
Actually, you know what? I think I can answer this one myself. So I monitor my usage, which keeps my bills down, and you can do the same. So keep an eye on the thermostat, try not to use the heater or air conditioning too much, and avoid long hot showers. I know, that last one is really hard, but it does make all the difference. All right, see you, Frédéric, and remember to hit the lights on your way out.
One thing Vanessa forgot to mention, if electric current represents the flow of an electric charge in a given circuit, that charge travels from the highest point with the highest electric potential to the point with the lowest electric potential. This is why voltage is also referred to as potential difference. Voltage makes electrons circulate through a given conductor. In other words, voltage is the amount of pressure applied to the current. And that current always goes from a high point to a low point, just like a waterfall flowing down a mountain. And so, the flow of electricity through a circuit creates a continuous supply power. But there is more. Why does it take pressure or voltage to push electrons through a circuit? When electrons flow through conductive materials, they encounter resistance. The greater the resistance, the more difficult it is for the electric current to flow. Resistance depends on the atomic structure of the conductive material. Metals such as silver, copper, gold, and aluminum are excellent conductors. Some materials have no electric resistance in special conditions. These are called superconductors. They are so cool! We will get to them in a later episode. For now, have you ever seen this symbol? Omega is the symbol for the Ohm law, which is a representation of the relationship between an electric current, voltage, and resistance. The electric current always equals the voltage divided by the resistance. The electric current traveling through a conductor between 2 points is directly proportional to the voltage across those 2 points. For example, if the resistance is high, then the voltage or pressure must be increased to sustain electric current. That's how we can keep the energy flowing. Let us review. An ampere is a base unit used to measure electric current intensity, but voltage is the amount of pressure applied to the current. Power is the amount of energy used for a given utility measured in watts, whereas energy is the rate of power delivery measured in joule. Well, that's it for today, friends. Thank you for tuning in. Subscribe, leave a comment, give a thumb up, and remember to conserve your energy. The power is in your hands.